107 kilometers of solid rock is the only reason Colombia is counting its dead in the hundreds this morning, instead of the tens of thousands. Yesterday, the biggest earthquake anywhere on this planet in weeks tore through the ground beneath Chaco, a magnitude 7.4 that 34 million people felt across 4 countries. An airport terminal partially collapsed with people inside it. 61 buildings came down. But the most disturbing thing about this earthquake is not the damage. It is what the plate underneath Colombia has done to itself. At 12:34 and 28 seconds, Universal Time yesterday morning, a magnitude 7.4 earthquake ruptured beneath western Colombia. Local time was 7:34, a Monday, the start of the working week. The United States Geological Survey cataloged the event under the identifier US 6000 TJL2 and placed the epicenter within a few kilometers of San Jose del Palmar, a town of roughly 4,800 people in Chaco Department, in the far west of the country. Bogotá sits somewhere between 240 and 280 kilometers to the east, depending on which agency's epicenter you use. The first number to reach the wires was wrong. Colombia's own geological service put the magnitude at 6.6, and several international outlets ran with it before the figure was revised upward to 7.4 as more station data arrived. That revision is not a rounding error. It is roughly 16 times more energy released, but the magnitude is not the number that decides what this earthquake did. The number that decides everything is the depth. The USGS placed the rupture at 107 kilometers below the surface. That is 66 miles straight down. Colombia's Servicio Geológico Colombiano reported 96 kilometers. The European Mediterranean Seismological Center put it at 95, and the initial automated feed listed 110 before the solution was refined. Disagreements of that size in the first hours are routine, and they shrink as data accumulates. What every agency agrees on is that this rupture happened between roughly 95 and 110 kilometers down, which puts it squarely into the category seismologists call intermediate depth, conventionally defined as anything between 70 and 300 kilometers below the surface. Almost everything strange about yesterday traces back to that one figure. There are 3 separate physical reasons a deep earthquake behaves differently at the surface, and all 3 were operating yesterday. The first is geometric spreading. Seismic energy radiates outward from the rupture point as an expanding surface. And the further that surface travels before it hits the ground, the more thinly the same energy gets spread across it. A shallow rupture dumps its energy into a small patch directly overhead. A rupture at 100 kilometers has spread that same energy across an enormous area by the time it arrives. The second is anelastic attenuation. Rock is not a perfectly elastic material. As seismic waves travel through it, some fraction of their energy is converted into heat by internal friction, and that process strips out high-frequency energy preferentially. High frequency is the sharp, violent, short wavelength content, the jolt that snaps unreinforced masonry. 100 kilometers of rock acts like a filter, and what comes out the other side is the slow, long-period rolling motion that survivors from Quito to Panama City described yesterday as feeling like standing on the deck of a boat. The third is that there is no fault scarp. A shallow earthquake can tear the ground open, and it generates a family of destructive near-fault effects. Directivity pulses, permanent ground offset, the violent close-range phenomena that flatten everything within a few kilometers of the fault line. None of that exists when the rupture is 100 kilometers below the nearest building. The USGS noted that the absence of surface rupture makes it harder for rescue teams to identify the most severely shaken zone from the air because there is no line on the ground to follow. Here is the part left out of the reassuring version of this explanation. The filtering is not uniformly protective. Long-period energy survives the trip, and the structures most responsive to it are the tall ones, the mid-rise ones, and the ones with long-span roofs. Deep earthquakes are not harmless. They are selectively harmful, and they select differently than shallow earthquakes do. Hold on to that, because it explains the damage map. The USGS estimated that roughly 34.4 million people across 4 countries felt this earthquake. Colombia, Ecuador, Panama, and Venezuela. About 1.9 million experienced very strong shaking, 14 million strong shaking, 12.9 million moderate shaking, and 5.6 million felt it lightly. The town at the epicenter has a population of about 4,800 people. The deaths did not happen there. As of yesterday evening, the confirmed toll stood at least 111 killed, and it was still climbing. It began the morning at 2. It went to 20. It passed to 70 in the afternoon. By evening, it was 111. Anything quoted today is a first-day count from the places that are reachable, not a final figure. The geographic distribution is the tell. At least 40 of those deaths were in Risaralda department, where Pereira sits. At least 27 were in Valle del Cauca, which includes Cali. More deaths and damage were reported in Caldas, Antioquia, and Choco itself. Alongside the fatalities, at least 87 injured, 61 buildings collapsed outright, 1,575 homes damaged, and the president putting total damaged buildings above 1,600. 18 health centers, 52 educational centers, 17 community centers, and 18 roads were also damaged. Pereira and Cali sit on the far side of the Western Cordillera from the epicenter, in and around the Coffee region, well to the east, up in the mountains. And that is precisely what deep earthquake physics predicts. Because no single point at the surface takes the full force of the rupture, the damage distribution stops being governed by distance from the epicenter and starts being governed by soil conditions, building stock, and which structures happen to resonate with the long period motion that made it through. A 4-story building partially collapsed in Manizales. 20 structures came down in Cali. That is what selective harm looks like on a map. In Bogota, where more than 8 million people live, buildings cracked, alarms went off, and workers poured into the streets. But the initial morning assessment reported no significant structural collapse in the capital. In Quibdó, the capital of Choco, the departmental governor confirmed injuries and building damage and said teams were still conducting a first assessment. Armenia, in Quindío, reported damage as well, and Armenia's name is going to come back before this is over. Colombia's president, Abelardo de la Espriella, 3 days into his term, declared a national disaster. He convened a unified command post at the National Disaster Agency and announced he would travel to Pereira. The single most dramatic piece of confirmed infrastructure damage was at Matecaña International Airport in Pereira. The passenger terminal partially collapsed. Video from inside the building shows a section of ceiling and roof structure detaching and coming down into a public area with people present. Matecaña is one of the main air links serving the Coffee region, and it was not the only one hit. Colombia's Civil Aviation Authority suspended operations at 7 airports while inspectors went through them. Matecaña in Pereira, La Nubia in Manizales, El Edén in Armenia, El Caraño in Quibdó, Santa Ana in Cartago, Gerardo Tovar Lopez in Buenaventura, and Alfonso Bonilla, Aragon, serving Cali. An airport terminal roof is a long-span structure, and a 4-story concrete frame has a natural period far closer to the energy a deep earthquake delivers than a single-story house does. This is not a coincidence in the damage record. It is the physics from a minute ago showing up in concrete. Then there are the 2 hazards that operate independently of shaking. The USGS estimated that liquefaction affected an extensive area with an extensive population exposed. Liquefaction is what happens when water-saturated soil temporarily loses its bearing strength during shaking and starts behaving like a fluid. Foundations sink, buildings tilt, and buried water mains and sewer lines shear apart. Choco is one of the wettest places on the planet. Its soils are saturated essentially all the time, and that makes the department unusually exposed to this specific failure mode. The second is landslides, which the USGS estimated affected a significant area with a significant population exposed. Andean terrain plus permanently wet soil is close to ideal conditions for slope failure, and landslides triggered yesterday morning may have cut the few road links into Choco before any assessment team could travel them. And it gets worse. The USGS flagged that the predominant construction in the most heavily shaken zone is mud wall with wood, the category most vulnerable to seismic shaking anywhere in the world. The agency's economic loss estimate came in below 1% of Colombian gross domestic product. Those 2 facts together describe this disaster exactly. The financial exposure is modest because the affected region is poor, and the human exposure is high for the same reason. Choco is among Colombia's most economically marginalized departments. Much of it has no paved road access, and the terrain is dense rainforest. Rescuers who reached Pereira within hours may need days to reach the most remote communities. That gap is the largest single source of uncertainty in the casualty numbers, and the USGS put roughly a 1 in 3 probability on the final toll, exceeding 1,000. Here is the detail that has seismologists watching rather than relaxing. In the hours after the main shock, catalogues listed 1 aftershock, a single magnitude 5.0 at 13:18 in 10 seconds. Universal time, 44 minutes, after the rupture at about 98 kilometers depth, roughly 16 kilometers west of San Jose del Palmar. 1. For magnitude 7.4, that is a strange number. A rupture that size would normally generate several events in the magnitude 6 range and a whole population of magnitude 5s inside the first day. And this is not a detection problem in the obvious sense. The same regional networks routinely catalog magnitude 2 and magnitude 3 events up and down the trenches on either side of Central and South America. They see small earthquakes. They just were not seeing many here. Two honest caveats belong on that. The first is that the window was short. The count was taken within hours, and aftershock catalogues fill in over days. The second is that deep earthquakes inside a descending plate are known to produce sparser sequences than shallow crustal earthquakes of the same magnitude, because rock at that pressure and temperature responds to a stress change differently than cold, brittle near-surface crust does. A quiet first day is not automatically an alarm. What makes it worth watching regardless is the question of where the stress went. This rupture happened inside the descending slab, well below and well inland of the locked plate interface offshore. The question a seismologist asks after an intraslab earthquake of this size is whether the deformation loaded anything upward, toward that interface, where the truly enormous earthquakes come from. As of last night, there was no sign of activity migrating toward the coast, toward Venezuela, or south toward Peru. That is the honest state of play. No evidence of stress migration, and a watch window that has now shrunk to about the next 24 hours before the aftershock pattern starts giving a real answer. Colombia has already run the experiment that shows what yesterday would have looked like if the rupture had been shallow. On the 25th of January, 1999, a magnitude 6.2 earthquake struck the central Colombian Andes. Its hypocenter was 17 kilometers deep, and it sat almost directly beneath the densely built urban fabric of the coffee region. The mechanism was left lateral strike-slip faulting on a fault segment running parallel to the Andes, most likely within the Romeral fault system. It killed 1,185 people, more than 4,370 were injured. Roughly 160,000 people were left homeless. The city of Armenia, then home to about 300,000, lost around 60% of its building stock to collapse or severe damage. That earthquake rewrote Colombian seismic building codes. Now put the two side by side. Yesterday was a magnitude 7.4. 1999 was a magnitude 6.2. That difference of 1.2 magnitude units corresponds to approximately 63 times more energy released yesterday. Both events were strike-slip. Both hit the same general region. Armenia itself reported damage again yesterday. 1999 killed 1,185 people. Yesterday, on day one, killed at least 111, 63 times the energy, a fraction of the deaths. The one variable that changed is depth. 17 kilometers then, 107 kilometers now. 90 kilometers of extra rock between the rupture and the people standing on top of it. There is an even closer precedent, and almost nobody is mentioning it. On the 8th of February 1995, a magnitude 6.4 earthquake struck at a depth of about 73.5 kilometers in the same corner of Colombia, and it damaged Valle del Cauca, Choco, and Risaralda, the same three departments that took the worst of yesterday. It killed 42 people. That was the same kind of earthquake in the same slab, hitting the same cities 31 years earlier. Yesterday was not an unprecedented event for this region. It was a bigger version of something Colombia has seen before. All of which leads to the obvious question. If depth is the variable that decides whether an earthquake is a news story or a national catastrophe, then what decides the depth? The answer is a structure most people have never heard of, and it explains the one thing about yesterday that genuinely puzzled seismologists. Start with the puzzle. When an earthquake happens inside a descending oceanic plate, the expected mechanism is normal faulting, the slab being pulled apart by the weight of its own sinking mass. That is the textbook result. Yesterday's rupture was not that. Agencies attribute it to strike-slip faulting horizontal shearing along either a northeast-trending left lateral fault or a northwest-trending right lateral one. Those two possibilities are mathematically indistinguishable from the seismic data alone, and separating them requires relocating aftershocks, which nobody could do with one aftershock on the books. But either way, the motion was sideways. Something is twisting the plate beneath Colombia, not just stretching it. The structure that does the twisting is called the Caldas Tear, and it is named for the Colombian department whose capital is Manizales, one of the cities where people died yesterday. Beneath Colombia, the Nazca Plate is not descending as a single coherent sheet. It is ripped. At roughly 5.0 to 5.6 degrees north, researchers have documented a west to east running tear in the slab, about 240 kilometers long, associated with a 240 kilometer east-west offset in the subducting plate. On either side of that tear, the plate behaves like two different objects. North of about 5.4 degrees north, the slab descends shallowly at a dip of 20 to 30 degrees, running almost flat beneath the country. South of that line, down to about 3 degrees north, it descends normally at 30 to 40 degrees. Inside that southern segment, there is a dense band of intermediate depth earthquakes researchers call the Cauca cluster, running from 3.6 to 5.2 degrees north at depths between 50 and 300 kilometers. The slab there is about 15 kilometers thick, dipping southeast, with the dip steepening from 20 degrees at the cluster's northern edge to 38 at its southern edge. Yesterday's earthquake happened at 4.88 degrees north at a depth of about 107 kilometers. That puts it inside the Cauca cluster, close to the boundary where the plate is torn. As for how the tear formed, the explanation runs through Panama. The Panama block is built of thick, buoyant crust, the remains of an ancient island arc, and buoyant crust does not subduct easily. It jams. When it collided with South America, the deformation from that collision is understood to have ripped the adjacent Nazca plate apart along a reactivated spreading ridge called the Sandra Rift. Something hit South America that could not sink, and the plate next to it tore. And a slab that is torn, offset by 240 kilometers, and forced to change its dip angle across that boundary is a slab under horizontal shear. Horizontal shear produces strike-slip earthquakes. The mechanism and the structure agree with each other. This should be stated as a well-supported interpretation rather than a closed case, because confirming that yesterday's rupture was specifically tear-related needs the aftershock relocation and moment tensor refinement that has not been published yet. But it is the framework that makes the strangest detail of yesterday's earthquake make sense. The tear does something else, and this is where it stops being a technical footnote. Published work on the Caldas tear states that the structure controls both the strong motion earthquakes and the recent volcanism of the northern Andes. One geological feature determines where Colombia's damaging deep earthquakes happen and where the country has active volcanoes at all. The volcanic consequence is visible on a map. The tear creates an offset in the volcanic arc, separating old, inactive magmatic bodies to the north from geologically recent and, in many cases, still active volcanism to the south. Colombia's active volcanoes exist only south of the tear. North of it, where the slab runs flat, the arc simply stops. One line drawn across the country, and it governs two entirely different hazards on either side of it, which brings the story to a mountain about 285 kilometers south of the epicenter, on the other end of that same slab segment that had already been making news for 9 days before the ground moved yesterday. On the 1st of August, Colombia's Geological Service raised the alert level for Puracé volcano in Cauca Department near Popayan from yellow to orange. The change was driven by a persistent rise in monitored parameters starting on the 20th of July. The Observatorio Vulcanológico y Seismológico de Popayan recorded a sharp increase in the seismic energy of earthquakes located about 1 kilometer below the crater, together with rising temperatures in the ash emissions and increased gas output. Gas and ash columns have been reaching up to 3,400 meters above the summit, with estimated temperatures around 140 degrees Celsius. Those emissions are the strongest recorded at Puracé since 1993, the highest level in 3 decades of monitoring. In one recent 24-hour period, the observatory logged 6 separate ash emissions, and the local mayor declared a public calamity. The service has advised people to stay away from the craters of the Puracé, Piocolo, and Curiquinga complex. An orange alert in the Colombian system means the probability of eruption has increased. It explicitly does not mean an eruption is going to happen. Now the geography. Puracé sits at about 2.31 degrees north, 76.39 degrees west. Yesterday's epicenter was at 4.88 north, 76.21 west. The two are separated by roughly 285 kilometers, almost due north to south on very nearly the same line of longitude. Both sites south of the Caldas tear, above the same steeply dipping southern segment of the Nazca slab. They are, in the most literal sense, products of the same descending plate. That is a real connection, and it is worth stating clearly. What is not real is causation, and the claim is already circulating online that yesterday's earthquake means Puracé is about to erupt. The chronology runs backwards. Puracé's parameters started changing 3 weeks before the earthquake. The depths are incompatible. A rupture at 107 kilometers inside a subducting plate versus a magma system whose seismicity concentrates 1 kilometer below a crater. Earthquakes do sometimes modulate volcanic systems, but that is observed at short range, not across a quarter of a country. What is legitimate and genuinely worth watching over the next few days is whether the passage of strong seismic waves through an already restless system changes anything measurable. That is a real phenomenon. It has a short answer window, and the observatory's next bulletin is the specific checkpoint. The framing is not that one caused the other. It is that on a single Monday, one descending plate produced a lethal earthquake in the north of its arc, while running a volcano at orange alert in the south of the same arc, 285 kilometers apart. Three things are worth tracking, and all three have near-term answers. The first is the casualty figure, which is going to move. The gap between 111 confirmed deaths and the USGS estimate carrying a 1 in 3 chance of exceeding 1,000 is not a contradiction. It is the size of the area nobody has physically reached. Landslides may have cut the limited roads into Chaco, and numbers from those municipalities will arrive late for reasons that have nothing to do with concealment. Watch the departmental reports out of Chaco over the next 2 to 3 days. The second is the aftershock sequence. 1 magnitude 5 in the first hours is unusual for a magnitude 7.4, even allowing for the sparser sequences deep interslab ruptures typically produce. Over roughly the next 24 hours, the catalog should either fill in with the normal population of 4s and 5s, which settles the question, or stay quiet, which makes the sequence genuinely anomalous. Either way, the thing to watch is location. Whether any activity starts migrating westward and upward toward the locked plate interface offshore. There is no sign of that yet. The third is Puracé. The observatory publishes regular bulletins. The alert is already at orange, and emissions were running at a 30-year high before yesterday. Whether that alert holds, escalates, or steps back down in the days after a magnitude 7.4 in the same slab system is an open question with an answer coming soon. There is a fourth point, and it is less about the next week than about what yesterday actually demonstrated. The depth that limited this disaster is not a permanent feature of Colombia's hazard. The shallow crustal faults that produced the 1999 catastrophe run directly beneath the same coffee region cities that took the damage yesterday. Offshore, the locked plate interface that produced a magnitude 8.8 in 1906. One of the largest earthquakes ever instrumentally recorded, with the destructive Pacific tsunami, is a far more dangerous system than the one that ruptured yesterday. Yesterday showed exactly what those cities' building stock does when it is hit by filtered, long-period shaking from 100 kilometers underground. Terminal roofs came down, mid-rise buildings failed, more than 100 people died from an earthquake that had already given up most of its destructive energy before it reached anyone. That is the useful information here, and it says nothing reassuring about what happens the day the shaking starts 17 kilometers below instead of 107.